HyperConsciousness, the HyperBody, and the brain type 2. When I first began examining the bidimensional patterns created by projecting tissues onto a plane, I realized there was a significant correlation between these patterns and those generated by brain tissue itself. The similarities in functionality between these two-dimensional representations of both tissue and brain processes became evident. However, in this scientific work, my goal is not to make inferences, but rather to present the correlation. This is precisely the purpose of this article. We are identifying a fascinating connection, one that is valuable for us to explore further. By focusing on this correlation and working empirically, we could potentially train the brain in the same manner that we train the functionalities represented by other tissues in the body. This approach, using non-cognitive activities aligned with these bidimensional patterns, could lead to similar outcomes, enhanced human performance. This is the motivation behind my work, and the reason I began with this chapter. It's critical to reconsider how we perceive brain functionality, consciousness, and tissue performance. They may be more interconnected than we've previously thought. When we examine these geometrical patterns in 2 dimensions as expressions of 3-dimensional structures, we open the door to a broader understanding. This leads us to consider the possibility of a hypergeometrical structure, a kind of higher dimensional body and consciousness. If we accept that the brain is the vehicle for consciousness, then this hypergeometrical body must have its own vessel for consciousness as well. By recognizing that 2- and 3-dimensional geometric patterns are linked to cognitive, emotional, and sensory functionalities, I propose that the same applies to the HyperBody. The brain, in this view, the 3-dimensional tissue patterns, and the correlated bidimensional tissue patterns in the body may act as an antenna, bridging the gap between the functionality of the HyperBody and the functionality of our physical body in this realm, in this dimension, and within this specific quantum version of reality. Thinking along these lines, the studies we will explore throughout this book will help us deepen our understanding of our current situation, the nature of the body, intelligence, and functionality. But equally important, we must consider our HyperBody, the aspects of ourselves we haven't yet fully explored. What are we, truly? What is the essence of being human? What does it mean to exist in this universe? As we move through this exploration, we'll begin to uncover new dimensions of what it means to be human, what we are made of, and where we really are. The diversity of bidimensional tissue patterns and correlated tissue and brain functionality toward a new type 2 brain. For decades, neuroscience has focused on the brain's 3-dimensional structure, compartmentalized into regions responsible for cognitive, motor, and sensory functions. However, emerging research into bidimensional geometrical patterns found in various human tissues and organs suggests a new framework for understanding brain and body functionality, which we can term the type 2 brain. This novel approach centers around the idea that the body and brain's functional processes can be represented as bidimensional patterns projected onto 2-dimensional planes. These patterns include fractals, waves, spirals, grids, concentric circles, and vortex-like structures. Each of these patterns is shared by different tissues, linking the brain's function to the organs it governs. The type 2 brain model recognizes the importance of these geometrical designs in shaping the body's regenerative capacity, functionality, and potential for performance enhancement. In this article, we explore the diversity of these tissue patterns, their correlated brain and organ functions, and how this conceptual shift could transform our understanding of perception, cognition, and enhanced human performance. The bidimensional projection of tissue patterns. 1. Fractal branching. Projection on plane, fractal branching appears as recursive, tree-like bifurcations when projected onto a 2-dimensional plane. These patterns are present in various tissues such as the lungs, vascular systems, and nervous networks. Correlated functionality. Tissue, fractal branching ensures efficient distribution systems for air, lungs, blood, vascular systems, and signals, nervous systems. The fractal structure allows for maximal coverage with minimal energy expenditure, optimizing the flow of oxygen, nutrients, or information across large areas. Brain. In the brain, Fractal-like branching mirrors the organization of sensory processing pathways where hierarchical signal processing occurs. This pattern is present in systems like the visual cortex, olfactory bulb, and auditory pathways, where inputs are refined and integrated. Implication for the Type 2 brain. In the Type 2 brain, fractal projections represent how the brain processes and refines sensory inputs efficiently. These projections allow information to be distributed across broad networks in a layered, hierarchical manner, revealing how sensory attention and multitasking are managed by fractal hierarchies. 2. Wave-like patterns. Projection on plane. Wave-like patterns manifest as undulating curves, often repeating in regular intervals. These are seen in muscle fibers, the retinal layers of the eye, and the folds of brain tissue. Correlated functionality. Tissue. In muscles, wave patterns facilitate coordinated contraction and relaxation, optimizing motor control and movement precision. In sensory tissue such as the retina, these patterns help in the spatial arrangement of cells that detect light and movement. Brain. In the brain, wave dynamics are reflected in electrical rhythms, such as alpha, beta, and theta waves, that regulate various states of cognition, attention, and consciousness. Neural oscillations also support sensoromotor synchronization, ensuring the brain aligns movement with sensory inputs. Implication for the Type 2 brain. Wave-like patterns in the Type 2 brain demonstrate the importance of oscillatory rhythms and synchronization across brain regions. These projections help regulate sensory perception, motor control, and attention by maintaining resonant frequencies within the brain's neural circuits. 3. Spirals, helical patterns. Projection on plane. Spirals and helices, when projected onto a plane, appear as coiled curves or expanding circles. They are found in organs such as the cochlea, nasal passages, and muscles. Correlated functionality. Tissue. In the cochlea, spiral structures efficiently process sound waves. In nasal passages, spirals regulate airflow. In muscles, spiral fiber arrangements enable smooth force transmission and movement. Brain. Spiral dynamics are involved in auditory processing, as the cochlea translates sound waves into neural signals sent to the brain. The helical pathways in neural tissues help the brain manage continuous, flowing information, optimizing sensory and motor control. Implication for the Type 2 brain. Spiral projections in the Type 2 brain reveal how sensory and motor information is streamlined and efficiently processed. This structure allows for continuous data flows, like sound or motion, to be condensed and interpreted. Such patterns can be applied to enhance artificial neural networks or sensory augmentation technologies. 4. Concentric circles. Projection on plane. Concentric circles are organized around a central point, resembling rings that radiate outward. These are present in structures like the eye, retina, and cornea, and in the skin's vascular networks. Correlated functionality. Tissue. In the eye, concentric layers are essential for focusing light precisely onto the retina, enabling sharp vision. In vascular networks, these patterns help distribute blood around focal points, maintaining optimal nutrient and oxygen flow to vital tissues. Brain. Concentric circles in brain organization reflect centralized control systems, particularly in sensory processing. For example, the visual system relies on concentric focusing to manage visual stimuli, allowing the brain to prioritize central objects while minimizing peripheral distractions. Implication for the Type 2 brain. Concentric patterns in the Type 2 brain highlight the organization of focus and control mechanisms. These projections enhance understanding of how attention is directed and maintained, offering insights into training focus-related cognitive abilities, such as visual attention or meditation practices. 5. Grid-like networks. Projection on plane. Grid networks consist of intersecting lines, forming squares or rectangles. These structures are found in neuronal connections, muscle fibers, and even vascular tissues. Correlated functionality. Tissue. Grid-like patterns support precision and coordination in tissues, particularly in muscle contractions and neural signal transmissions. These grids allow for the synchronized operation of large, complex systems. Brain, in the hippocampus, grid cells enable spatial navigation by creating mental maps of the environment. This pattern also supports motor coordination by mapping space and time onto neural circuits, allowing for precise movement control. Implication for the Type 2 brain, grid patterns reveal how the brain maps and navigates both physical and conceptual spaces. The Type 2 brain uses grid projections to coordinate movement, spatial reasoning, and problem-solving, offering potential applications in enhancing spatial awareness and memory. 6. Vortex-like patterns. Projection on plane, vortex-like patterns resemble spirals but with a distinct swirling motion toward a central point, creating rotational dynamics. These patterns are especially significant in the heart and lungs, where fluid dynamics are crucial. Correlated functionality. Tissue, vortex-like structures optimize the flow of fluids, such as blood in the heart and air in the lungs. In the heart, vortices enable efficient pumping of blood with minimal energy expenditure. In the lungs, they enhance airflow dynamics, improving oxygen exchange and lung capacity. Brain, vortex-like patterns in neural tissues relate to the efficient organization of large-scale brain networks, particularly in memory consolidation and attention modulation. The swirling nature of these patterns helps the brain integrate and distribute information across different functional areas. Implication for the Type 2 brain. In the Type 2 brain model, vortex projections offer insights into how the brain manages large-scale, integrative tasks like memory processing, attention, and decision-making. By understanding these patterns, we can enhance therapies for cardiovascular health and cognitive functions related to focus and memory. How the Type 2 brain works. The Type 2 brain framework views the brain as operating on bidimensional functional maps that correlate with key physiological and cognitive processes. These maps offer new insights into how the brain manages sensory integration, motor control, emotional regulation, and memory consolidation. Pattern recognition. The brain may be using these patterns, identified through our study as bidimensional projections, to detect and process patterns in both the external environment and internal physiological states. Functional segmentation. Geometrical projections allow us to divide complex tasks into manageable segments. For example, fractal branching enables the brain to handle hierarchical information processing, while wave-like oscillations synchronize regions for smooth execution of tasks. The respective correlations into other tissues' functionality support the brain Type 2 framework. Dynamic synchronization. The brain's use of wave-like and vortex patterns allows it to dynamically synchronize activity across multiple regions, facilitating rapid response and adaptation to changing stimuli. Accelerating performance and cognitive enhancement with the Type 2 brain. By tapping into the bidimensional patterns projected from the body's tissues, we can unlock advanced techniques for cognitive training, physical performance, and regenerative medicine. Understanding the geometrical patterns within organs such as the heart, lungs, muscles, and brain offers opportunities for optimizing human functionality without relying on prosthetics or external devices. Neuroprosthetics, mimicking these geometrical projections, could revolutionize the design of prosthetics and sensory augmentation technologies, enabling more natural integration with brain processes. Cognitive enhancement. Targeted cognitive training that leverages these bidimensional patterns, such as improving wave synchronization or fractal hierarchies, could enhance memory, focus, and sensoromotor integration. Regenerative medicine. Therapies aimed at restoring the brain and body's natural geometrical patterns could accelerate recovery from injuries or diseases, tapping into the body's own regenerative blueprint. The exploration of bidimensional tissue patterns and their associated brain functions offers a profound new perspective on human physiology and cognitive performance. The Type 2 brain concept suggests that we can enhance sensory processing, motor control, and cognition by understanding and optimizing the geometrical projections shared by tissues and the brain. This framework opens new possibilities for neurological therapy, cognitive enhancement, and overall human well-being.